Hello everyone. I am Saptarshi Mukherjee. I am a software engineer 3 at Google and a competitive programmer. So, I have been a master at Codeforces and currently I am a candidate master at Codeforces. So, this video is about this particular round 937 div 4, which I am about to start. The round is about to start in around 2 minutes 50 seconds. I'll be participating in this contest live, and through this video I'll be showing you how I actually take part in contests. Some aspects will be a bit slow. For example, I'll be coding in this VS Code, which is otherwise fine, the speed is fine, but currently because I'm multitasking, the speed will be a bit impacted. Might be a bit impacted, especially the execution speed. But while discussing, I'll basically use this page as a rough page. So whatever rough things we do during solving these problems, I'll be doing it on this page. So this is not this is not going to be a basic explanation of how I'm reaching a solution through intuition, etc. But I'll tell you the exact things that I'm thinking, and they'll be pretty short, I would say, but still from those steps you can actually recreate the solution yourself. So yes, the contest is about to start. As many of you would be able to relate, a live contest is always different from just a contest editorial kind of thing or solving a contest. So here I'm participating live, and also this is the first Div 4 contest I'm participating in. So I'm expecting Div 4 contest will be in many ways easier than Div 2 and Div 3 contests. I hope many of you will be participating in this round. So this is the first Div 4 contest that I'll be participating in, because in my time when I used to code regularly, we didn't have Div 4 contests. So I'm excited to see what's there. And I see three writers, two candidate masters, one master, who have authored this round. Um, I haven't actually participated in any contest before which they have authored. So I'm also interested to see what kind of problems come up. It's going to be expeditious in a number of ways, and I'm excited about what comes. So I'll be writing down all those small things here, and I'll be coding over here. So yeah, let's see. I don't know how many I'll be able to solve. I'll try to stay through these 2 hours 15 minutes, and I hope that by looking at this video you'll be able to get some fresh insights of how you can solve these problems. Okay, so countdown. The last 10 seconds. It's a bit slow, we can't do much. Okay, there we go. Three digits A, B, and C. Stair, peak, or neither. Stair basically means increasing, peak means increasing and then decreasing. So, fine, it's a brute force kind of thing. Not much to do. Input ABC and do those steps. C. And I'll say that, okay, if it's a stair, that basically means if A is less than B and B is less than C, then pw.println, it's a stair, right? Stair. Else, if it is increasing and then decreasing, so A is less than B and then B is greater than C, then we will call it as a peak. Otherwise, it's it's uh, it's none. Well, there is nothing to see over here. T is there, that is fine. So I'll straight away submit it without wasting any time. None, peak, stair. So should be fine. Let us see. Okay, it's in queue as expected. There are 40,000 people who had registered, 40,000 plus. How many are actually participating? We don't yet know. We'll come to know about that from the standings. That's a simple if else thing. I'm unsure why it took 2 minutes, 1 second. I felt I had done it within 2 minutes, but doesn't matter. Okay, it might take some time. We can offer that time. We can move to the next question. Upscaling. Now this is a 2D array, 2n cross 2n, both even and square, alternating hash and dot, uh, with the top left cell being hash. So we have hashes, then we have hash hash dot dot hash hash dot dot. Okay, so 2 cross 2. In that way, it's alternating. And now need to output a checkerboard. Okay, this is also brute force kind of a thing. Um, so I think n divided by 2 and um, hmm, I think if both the row by 2 and column by 2 are even. So what I'm currently actually looking at is, if I look at something like this, since it is going in batches of 2, so I'll be actually happy to take in batches of 2. So I will say that, okay, whatever row number you have, let's say this R and this C, compute R by 2 and C by 2. And then one way is, if both are even, then it should have a hash. That's my understanding. Yes. If both are odd, then also hash. So it's a XOR kind of a thing. So I'll basically XOR them up. So something like, take the element at AR, uh, not the element, basically something like this. R by 2 XOR C by 2 and modulus 2. That is going to give me, if it is even, I should put a hash, which is the case for this guy. If it is not so, I'll put a dot. That's, I think, my understanding. Let us see. Okay, the site is struggling. That's expected. We can utilize our time better over here. We just have to take n. Then I'll say, okay, for int I equals to 0, I less than 2 into n I plus plus. And for, okay, I think we don't need int because I have I defined above. I'll use the same thing for this one, j less than 2 into n, j plus plus. And then I'll say, okay, int d is equal to I by 2 XOR j by 2 modulus 2 modulus 10 modulus 2 it should be. And then I'll say, okay, if d equals to 0, that means it's even. And then I'll say print pw.print hash, sorry, hash else pw.print, you can use ternary operator, hash, and we have a dot, and then I need to put that extra line, so it will be pw.println. Yeah, this should work. I don't expect it to betray. Okay, okay, this one is fast. Yeah, this is working. This is the exact pattern which is required. So I'll go there, put the code. Yeah, you can do a more, I mean, a different way, sort of. You can do a modulus by 4 and you can see, okay, is the modulus by 4 less than 2 or greater than equal to 2? If less than 2, then I mean that falls in one category. If greater than equal to 2, that falls in another category. If both row and column fall in the same category, we have the hash. So you can see this is like the same behavior for row and column. This is again same behavior for row and column. Okay, row and column both lie in the same kind of range. If we divide row by, if we do a modulus by 4, and if I then compare it, it can be greater than equal to 2, it can be less than 2. This is my distinguishing feature. Another distinguishing feature is directly r by 2. That's what I'm doing. So in this way, by zoring over here, I'm directly getting the answer. So I zored over here. There are multiple ways you can do in those ways. This should work. I think the Q has become slightly better, but we have to wait for some time. Fine, let us move to C. Time in 24-hour format, output the equivalent time in 12-hour format. Okay, 24-hour format divides the day into 24 hours from 00 to 23, each of which has 60 minutes from 00 to 59. 12-hour format is this. We have to convert to 12-hour. Okay, first, okay, AM and PM, fine. We, I think, know this already. Hours are numbered in the order 12 and 11. So we don't have 00. Unlike this one, we have 12. Each hour has, okay, and uh, let me see if we have some 12 p.m. kind of thing. Okay, 12:00, this should be 12 p.m., right? 12:00 p.m. Okay, not a big deal. What do we have? We have hours and minutes. Fine. So one thing is modulus 0, or I can say plus 1 modulus 0 or modulus 12, something like that. I mean, so I'm thinking of some. So basically, for all these numbers, for all these hours, I can do a modulus 12. If I do a modulus 12, I'll get it. For only the 12, I'll get a 0. I can handle that separately. That only we can do. So instead of applying any more mind, I can just implement that way, whichever is easier. So T is there and then S in this particular format. So char ch equals to sc dot next dot to char array. I'm taking it in the form of our character array. The entire thing will come. And then I'll say hour. Okay, it will be of length 5. That is a good thing for me. So I'll say, okay, the hour basically is ch 0 minus 0 multiplied by 10 plus ch1 minus 0, and I'll take m over here. So this is for the third and fourth, the minute. So in this way I have got the minute and the hour. And now int the new h, I'll name it as nh, is equal to h modulus 12. If nh is equal to 0, then I'll write nh is equal to 12, and then I'll come outside and say, okay, pw.println nh plus the colon plus the m unchanged, and then I can put a ternary operation depending on where h is. So if it is from 0 to 11, it should be am. So if my h is less than 12, then I will call it as am, otherwise pm. For this kind of question, again, I would directly submit, but because the submission and verdict is taking so much time, okay, you need a space, otherwise it will be a wrong answer. Yes. Yeah. Since it's taking so much time to judge, so the better thing is actually to test it out here. Okay, we got something. 9:41 a.m. 6. We need that thing. 9:41 a.m. Mm-hmm. So basically, string NHS is equal to, we need the zeros. We need those leading zeros. That's an interesting thing. So plus NH. If NH is less than 10, then NHS is equal to 0 plus. There are many ways of doing this. And this is a boring thing to do. You get this only in div 4 rounds. But okay, if you have got this, if I've signed up for it, then I have to do it. So the minute string ms, we have m, and I'll say if m is less than 10, then m and ms. Sorry, it should be ms. Yeah, 0 plus this, I'll write nhs and ms. Now it should be correct. Okay, now we have got it in the required format. 9:41 a.m., 6:06 p.m., 12:14, 12:59. Okay, it's 0:14, 0:59. Why is it so? Okay, I need this. I need this before. That's the reason. NH, this needs to be before. If it is 0, then it has to be corrected. Yeah. So I had actually converted that 0 to 12 later on. I need to do that before that. Otherwise, it becomes wrong. Okay, now I have 12:59, 12:00 a.m., 12:59 a.m., and then 2:34 p.m., 1:1 a.m., 7:07 p.m., 11:59 a.m. Looks good as of now. 12 p.m., 9:37 p.m. That's good. Okay. Fine. Previous one accepted. That's good to see. So now let's move on to D. Product of binary decimals. That's interesting. Binary decimal, if it is a positive integer and all digits in the decimal notation are either 0 or okay. Represent n as a product of some binary decimals. Okay, this is interesting. Not necessarily distinct. Okay, some binary decimals. The first thing that comes to my mind is why not multiply with 1 only? So can it be represented as a product of binary decimals? Okay, if a certain non-binary number or any general number, so n is a general number, can be represented as a product of some binary decimals. Interesting. So 121, we know it's 11 into 11. 14641 is again. Okay, now we have a lot of yes. That is interesting. Where do we have no? Let us see. This one we should have yes. 99 we should have a no because it is not possible. Hmm. So one thing that is coming to my mind is uh, it has to, I mean, if it ends with 0, that gives us something. Otherwise, it will be a product of some binary number. So we can truncate the zeros at the end. 1011 is possible if 1011 is possible. I mean, so basically, one of the given examples is 10110. We can say this is possible if 1011 is possible. Why? We can multiply by 10. So it is 1011 divided by 10. Okay, why can't I do multiply by 1 every time? Let me look at it. 121 equal to 11 into 11. Okay, yeah. Over here, I mean, if your given thing is binary, you can definitely do that thing into 1. but it can be something like 121, where you cannot do 121 into 1. Those two things need to be binary. I think two things are there. So yeah, it will be 11 into 11. That is fine. Okay, brute force is coming to my mind, and that raises the question: how many binary numbers will we find up to 10 to the power 5? Up to 10 to the power 5, we have basically 4 digits. So each digit has two options: 2 into 2 into 2 into 2. Can we say this? Each digit has two options. So we have total 16 possibilities, right? That's it. We have total 16 possibilities. So we can find out those possibilities uh, by a brute force kind of thing. We'll find out those possibilities. Okay, this is interesting. T is this. So we can't find out every time. Uh, we can find out in the beginning what are those possible binary numbers. There are 16 possible binary numbers up to 10 to the power 5. That is our understanding, which is good. And now okay, on multiplying each of them. So 16 squared is 256. We can multiply each and see. So 16 squared 256, not at all a problem. So 256 multiplications I will do, and then what else? I'll do this for these many test cases. So it will be 256 into 5, 5, right? 5 into 10 to the power 4, which is 1280 into 10 to the power 4. So 1.28 into 10 to the power 7, correct? Less than 10 to the power 8, so it works. So I'll generate the numbers. That's it. So outside this, I'll generate those numbers. Array list integer AR equals to new array list. Yeah. Okay, I wrote arrays list. Okay. What else? Now for I equals 0, I less than equal to 1, 2, 3, 4, 5. I plus plus int j equals to, sorry, j equals to I, let's say. Then I'll say while j modulus 2, sorry, j modulus 10 is, while j is greater than 0, we'll continue this. If j modulus 10 is less than 2, sorry, is greater than equal to 2, then this is not a binary number. I'll say continue. Continue that for loop. Which for loop? Let me name it. So this is R, let's say. So I'll say continue R. Continue the next number. I could have said break also. Yeah, but okay, continue R. Then I'll say j equals to j divided by 10. And so on. At the end, if I've reached, that means I is a possibility. AR dot add I. So these are my numbers. At the end, I'll do something like this. Char. I'll just take the integer, which is n. So int n equals to sc dot next int. Okay, now 10 to the power 5 and 10 to the power 5 can actually give me a long value. So integer overflow can happen. I have to avoid that. Ideally, I should take this in long. So now I'll say, okay, if long answer equals to 1, I'll do it differently. For int x in AR and for int y in AR, I'll basically say that if x into y, before that I'll typecast to long, if this is equal to the n. Okay, I didn't need long over there because I knew that it will be int. Here I don't need long. So if it is equal to n, then I'll say pw.println yes, and then I'll continue u, else I'll come down, and at the end I'll say, okay, it is not possible, print no. Six yes, 4 no, 1 yes. Let us see what we get. 6 yes. Oh, 1 no came. 1 2 3 4 5. 1 2 3 4 1. Good. So let us see uh, why it is so. Mm-hmm. Greater than equal to 2, nothing wrong with that. While j greater than 0. I don't see anything wrong with that. What is that example? I'll look at that example. The second one I think came wrong. Sorry, the third one. So the third one says 1. Ah, for 1 it is 1 into 1. So is my 1 not coming? 0, 1. 1 should come. 1 modulus 10. Then 1 divided by 10. 1 should be added. 1 modulus 10 is not greater than equal to 2. So it should be added while, yeah. So let me do something like this. System.out.println. I'll print I. And I'll add a space before that to indicate that I'm printing that thing. So slightly unexpected keeping this algorithm in mind. This int x and int y might be a difficult thing. Okay, so 1 is coming. So the only place we can see a problem basically is okay, it's not 1, it's 14641. I'm sorry. 14641. Product of sum. Ah, I'm sorry. Product of sum. Then we can do a different kind of a thing. We have 16 numbers. So with each number, we can actually create that set of numbers. That can be it's difficult actually, but it is possible. Hmm. So what I've implemented is actually for two binary decimals. Can it be expressed as a product of two binary decimals? But I need sum. Now, what is this sum? How many can it reach? If I sort of try to find that, um, mm, it will be at least 10. Yeah, it cannot be 1. 1 we should not multiply so many times. So at least 10 we will need. 1 and 0 we should not need. So that means at most 5 different multiplications I need. So I can actually find out all possibilities by actually multiplying them 5 times each. Hmm. This I can do at the beginning. So what we can do is something like this. Each can be present 5 times. And how many are there? 5 to the power 16. That is too much. But I'll say if it is growing beyond a certain point, then break it right over there. So it will go something like this. I will say, okay, you have 0, 1, that's fine. Then you add other new things. So it will be something like this 10, and then 10 square and all those things, which is 100, then 1000, then 10,000. And then I'll say, okay, put now 11 to each of these and see whatever you can get. So it will put to all these and say, okay, 1100, sorry, 110, 11000, and so on. If a number is already present, we can totally ignore that. If a number itself is present, we can say, okay, it was formed by two other. For example, when 110 will come, we will say, okay, it's already present. So 110 multiplied by 110 also has been considered, because 110 has been formed by um, 1 1, right? It has been found by 1 1. So 11 square also we would be considering 11, 11 square and so on. Then we'll be adding something like that. They should be pretty less. Hmm. They should be pretty less. Is there a guarantee that what is the maximum number? We can do it at the very beginning. We should not do it all the times. We should do it at the very beginning. But how many are possible? That number we know that that is pretty less. Is it 5 to the power 16? Let me think. Uh, there are 16 such numbers possible. If I remove uh, 0 and 1, then there are 14 such numbers possible. 5 to the power 14. 5 to the power 14 means around 2 to the power 5 to the power 14. What is it going to be? 5 to the power 14. That's a big number, and we are saying not all will be found. 6 2 5 1 5 3 5. So this is 1 2 3 4 5 6 7 8 9. So 6 into 10 to the power 9, a pretty big number. We can't endure so much. We are saying it won't be enduring so much. At any point of time we will have, yeah, so how many numbers will we be multiplying? For example, there are 16 such numbers. Each number has possible powers, let's say on average 3. I'm sure the average will be within 3. So 48 different multipliers. For example, like for 11, I'm basically taking 11, 121, and the next one 1331. These are the three possibilities. So I'm taking the average as 3 for each, like 11, 3 are possible. So now for 48, I'll say 48 will get multiplied with how many are there? I mean, 48 will, all of them will multiply with whatever are there in the list. They'll multiply and see whether they are a new addition. For example, 11, when 11 comes, 11 will multiply with each of these and add them, which is fine. What else? How many at the time, at any point of time will be there? 16. So it's 48 into 16, right? It's 48 multiplied by not 16, all their products as well. So it won't be 16 actually, but we can actually get an estimate. So it's 0, 1. I mean, it's not, there's no easy way to get that estimate. It won't be 16, but it should be somewhere around 1000 at the maximum. So I have that leap of faith and let me implement it then, and we will see if it gives a time limit exceeded thing. So instead of this, I'll get a hash set. I'll add 0 and 1 at the end. I'll say, okay, start from 10, go up to there. First check this, and let's name this as set. And now I'll check this, okay, are you, if j is equal to, if j is equal to, if set already contains j, if the set already contains uh, this I, then continue. Then we don't need to do anything, because we have already considered its multiples in that point. In that case, we have considered its factors, so that part is done. Otherwise, we will say, okay, set dot add I, right? And then I'll say, okay, again j equal to I, and do something like this. if while uh, is it while, let me think, wait, uh, so let's say j equals to I, or let me take a long variable long k equals to I. Then I'll say for int, okay, while this k is less than equal to 1 2 3 4 5, then only we are interested, and we will say add yourself and check others. Hmm. Hmm. Add yourself and then multiply with all of them. A good practice is actually to take another set, and then pour off at the end. So something like this. Take a set 1 and then say, okay, if, I mean, if k multiplied by, okay, sorry, so I'll do for int y in set. I'll say if y into k is less than equal to 1 2 3 4 5, then we are good. Set 1 dot add y into k, okay, and at the end we will come outside and say that whatever is there in set 1, add that in set. So into y in set 1, okay, we need to actually convert this back to int. We know it is less than equal to 1 lakh, so, or zero point 0.1 million. So this operation can be done, this typecasting can be done. And I'll say, okay, pour that in set. So set dot add y. Okay, this part is done. At the end, I'll do something different. I'll say, okay, you have k now. K equals to k into uh, I, right? So we are looking at the higher powers, and with that we will see what is there below. This is one way. This is the set. At the end, so this is the while loop. At the end, I'll come out and say that to your set, add 0 and 1. Set dot add 1. Okay. This should solve my problem. I'll just check pw.println set.contains n, yes, otherwise no. The time complexity is the only question that we need to ask. Set.contains in, yeah, no issues there. Logic should be correct. This one test case will verify that. Okay, all yes, then 4 no, then yes. So this should be correct. This should be correct. What I did, I just populated everything, and then and you can see this is the main thing. How much time I'm taking for this? Since it happened in the fraction of a second, so I can rest assured this is fine. Yeah, you see it's happening very fast. The initial part, that is the part which I'm interested in. So I'll submit it. Okay. So before this, the 3 submissions were correct, and this is running. So let me wait to see the result. Okay, test 2 also successfully ran. I'll wait till test. Okay, test 5 up to there successfully ran. Test 6 is running. Yeah, it's accepted. So fine, the logic was right. We used some loop of faith over there, but to some extent that's fine. Sorry, leap of faith. I'm really sorry. It sounded bad, but it didn't come to my mind. So it's a It was a leap of faith we used over there. We weren't sure exactly, but yeah. Now I'll work on the remaining. So yeah, there are some juniors who have solved things faster than me. Kudos to them. Nearly shortest repeating substring. You are given a string S of length n consisting of lowercase Latin characters. Find the length of the shortest string k such that several copies of k can be concatenated together to form a string with the same length as S and at most one different character. Oh, string question once again. Length n, all lowercase, length of shortest string k such that several copies of k can be concatenated to form a string with the same length as S and at most one different character. Okay, either the same string or at most one different character. Okay, concatenated means that means mostly they will be copies of each other with just one exception allowed. Interesting. Shortest length. Very interesting. Find the length of the shortest string such that this. Okay. So first of all, this k, I mean the length of k has to be a factor of the length of n. I mean has to be a factor of n basically. So shortest string k, yes. So basically c is equal to k plus dot 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 up to k, which means we are not taking a part of the string anywhere. So the length, I mean from this length we can find out what are the possible k's from the factors. That is cool. 10 to the power 3 and it says that okay, sum will not cross this. That means n squared algorithm is not permitted and big O n log n maximum n root n is possible. Okay, ABA. So from 4 we get the idea that it can be 1, 2 and 4. For 1 also it is possible. ABBA, only for 4 it is possible, right? Why ABA 1 it is possible? Because we can do something like this. ABAA. So if answer is 1, that means basically these are the different parts. So my string k will be equal to a, and I'll say there is only one difference. So this is my string, there is only one difference. I can have a. There is only one difference, that is here. One character should only be different. Otherwise it should be. It is possible over here. For ABBA that is not possible because two characters will be different, whatever way you try. Then something like this, Slavic, G Slavic. 13, it's a prime number, so only 1 and 13 are the factors. So either it's 13 or 1. 1 it is not possible because so many differences, you need the shortest, so 13, yeah, you have to rest with that. HS, ha ha ha. So that S is basically, So, factors. How many factors will a number have? Okay. So, a number can have how many factors? Maximum 2 root n factors. So we can find out all the factors, and then for each factor if I try to do this thing, then it will be root n, 2 into root n into n, which is fine. 2 into root 10 to the power 5 multiplied by 10 to the power 5. So 2 into the 10 to the power 5 means it is 300, right? 330 something. I mean, let's take 300 into 10 to the power 5. So 600 into 10 to the power 5, which means close to 10 to the power 8. But we have a hope. Finding factors takes some time, and then doing that takes how much time? Root n time. So okay, I think we are fine with that. Now, what should be our way of finding the factors? Should it be factorization of each number? 2 into 10 to the power 5. Okay, so it's not 10 to the power 5, it's 2 into 10 to the power 5, which means another 2 root 2 factor more, which means makes it difficult for n root n. So it is actually multiplied by 2 and multiplied by root 2. 2 into over here. So multiplied by 2 into 1.4. A bit difficult. But will we have so many factors? I don't think, right? If we take the smallest factors, what do we have? 1, 2, 3, 4. If we keep on doing 5, 6, dot dot dot, uh, let us find out how many factors at maximum we can have. This is a good way to find. So the product will be 2 into 10 to the power 5. 2 into 10 to the power 5. So how many factors can we have at max? The moment it reaches 10, after that I can say it can have at max 5. So the total will be less than equal to 15. Must be. Oh, so it's far better. They will not have root n number of factors. Something like this. At max they will have 15. So it's something like this. Uh, 2 into 15. This calculation that I did, is this correct? Uh, the product of all factors is not necessarily the number. There has to be something that this will give us. Okay, yeah. So I have to consider the prime numbers basically. So this is not the right way, but let's say it is divisible by some prime numbers. Let us say 2, and then 3, and then 5, and then 7, and then 11, and then 13. How far can it go? 17, 19. Now I feel it cannot go further. This will be, yeah. So it cannot go further from here. So which means that this is the maximum number of prime numbers. Maximum number of prime factors. This is not the only prime factors possible. There is a maximum number of prime factors. These are the smallest prime factors I've taken. If I multiply them, it will cross 2 into 10 to the power 5. I think so. Approximation. So the thing is, whatever number is given, number of prime factors will be less than equal to this. So what is this? 4 plus 4, that is 8. Hmm. Now, what is the maximum it can go from here? Product of all prime factors. Quite discrete, I would say. They won't be consecutive. So, not everything up to root n. Should be a bit different. Okay, it can be different. So, it can be something like this as well. 2 into 2 into 2 into dot 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 2. So, this means how many? Up to 10 to the power 2 into 10 to the power 5. How many such numbers can be there? 10 to the power 3, up to there can be 10. And then 3 and then 1, right? Sorry, 7 and 1, 8. So 18. 18 um, into 19 by 2, that is the number we get. The number of combinations of powers of 2, something like that. Mm. Hmm. Again, I have a leap of faith that this might work, but proving this is sort of taking a bit of time. So if I proceed with this, the idea basically is that my number of factors will be less than this number, less than uh, this number, root over 2 into 10 to the power 5. That number is 40, I mean 420, something like that. um, because 2's root is 1.414, so multiplying that by 300 we get something like that. So keeping that in mind, instead of 420, if we get lesser, hmm. What others? We can do a sieve of Eratosthenes. Will that help us? Okay, I was. Wait, I get the factors in root n time, but my number of factors. Let me search it because I'm forgetting that. What is the number of factors? The maximum number of factors of n. It is using that formula. So the prime factorization basically. Let us see what conclusion it is reaching. This is Cora, so you can't get much from here. Okay. Hmm. Cool. The thing is, for a small factor, if I get the answer, first of all, is it monotonic? No. Like if it holds for a smaller factor, I mean, if it holds for a certain factor, doesn't mean it will hold for all greater factors. So we can't apply binary search kind of thing. We have to look for all factors. But if we find a smaller one, we can break it right over there. That is one part of it. Hmm. Okay, so I can do that. Then what will I do? The moment I find that, then what will I do? I'll basically say, okay, let's say we have chosen some length L1. So this is your N. This is L1, here 2L1, here 3L1, something like this. L1, 2L1, 3L1, yeah. And then I'll match something like this. These should be the same. Count the number of differences. So whichever occurs the maximum number of time and whichever is the other one, we can do something like that. So if there are multiple numbers, if there is only one mismatch, fine. If there are multiple mismatches, we can break straight away for that. So fine, I'm having a bit of hope in this. Let me see. Hmm. Let us see. N S. So first for N, which goes up to 10 to the power 5. No, not first for N. I'll not do prime factorization. I'll try the easier method, which is find the factors at the point of. Hmm. So array list integer AR equals to new array list, and I'll say okay, for I equals to 1, I less than equal to, sorry, I into I is less than equal to N. What is N? N10 equals to the input I plus plus, and I'll say okay, input the number AR dot add I, sorry, if N modulus I equal to 0, AR dot add I, else we will say if, I mean, and also if I is equal to, if it is not equal to N by I, then we will say add N by I, AR dot add N by I. Hmm. Char ch equals to sc dot next dot to char array. What next? Okay, if it is a factor, then something like this. And then sort the factors. AR hmm. We can do this and actually find out that for n different numbers, how much time this is actually taking. So how many numbers? N root n is our requirement. So let us find out by doing this. N equals to 1, n less than equal to, n less than equal to 1, 2, 3, 4, 5. Actually 2 into 10 to the power 5. We won't get all, but I want to see how much time we are getting. I'm not worried much with the space. We can, I mean, clear the space later on, something like this ar.clear, because that is not my concern. I want to see the time that is taken. So one, and I'll put a simple thing. Okay, it took some time, I think. We have to wait for 1 second or so. How much time do we have here? 2 seconds. So if I measure the time, you can measure the time in this way. System dot out dot print, sorry, system dot uh, println system dot current time is divide by 1000, because I need the second. At the end, I need the second. Or let's see the granularity. We can't understand from the second always. I'll see how much time this basic thing takes. 1 okay, 3 so it happens within 1 second. It says it takes 6 milliseconds. I'll try it once again. 1 2 AB, yes. Now it takes 700 milliseconds. I'm fine with both of them, but also I need to consider the input times and all. But this is fine. I'm looking at all the numbers. But what if I look at the highest number? For that, basically it will be repeated. So we can use a hash map to prevent the same thing from happening so many times. And how many times? Basically, sum of n will be 2 into 10 to the power 5. So I'm relying on this actually. I'm relying on this. Here we have actually done more than that. Here we have done more than that. We have computed for all the numbers. In reality, it won't be all the numbers. But this is sum of root n over all the n, right? And we need sum of n root n over all those n. So it's slightly different. But from this we can say that each one will take how many milliseconds? Can we say that? So let's look over here. Long start is equal to this, and I'll do long end equals to this, and then over here I'll basically put long answer equals to 0. Sorry, I may have deleted something undesirably. Okay, I'll put here long answer is 0, long max, let's say, is 0, and over here I'll put max equals to max math.max max comma the end minus start, and at the end I'll print max. Yeah, now let's see. One 22 millisecond is the maximum for one number. Okay, so that must be for a big enough number. If we do that for 10 numbers, it will go to 1.2 seconds. That's big enough, but we can possibly manage. But we should avoid the same number from being queried so many times. That is a requirement. That's a good thing actually to add. So hash map array list integer map equals to new hash map. Okay, I don't know how much good this will do. Yeah, dot clear won't be there, no such max will be there. So over here we are sorting this here. We will say if map dot contains key n ar is equal to map dot get n, else this goes inside and we will add it ar. So map dot put n comma ar. Okay, I've sorted and I'll come outside and I'll say okay, let's do it for this n, for this factor, for each factor. So for int x in AR, in that order it will iterate. For x we will see that int boolean flag equals to true. That means till now nothing has been seen, no discrepancy. Now I'll say for I equals to 0, I less than, what is that, n, sorry, x, I less than x, I plus plus, and I'll say for j equals to I, j less than n, j plus equals to x. And then I'll say that if it doesn't match, count how many times it has not matched. With the first one, let's say, we have two options, with the first one and with the second one. So we can keep two different things, like int a1 is equal to the first one, that is ar dot get x, I think, no, it's I, and I'll say if okay, if x is equal to n, then pw.println n and continue. No use wasting time. Continue what? Continue this u loop. Sorry, yeah, this u loop. Otherwise, we have at least two. So we will write int. So if ar.get I plus x is equal to a1, then fine. So we need a frequency map kind of a thing, right? That is the easiest. That's the easiest. We can have a frequency map. We can say, okay, let's have this hash map integer frequency equals to new hash map. I'll store the frequency of every number that occurs. Free dot put j comma free dot get or default j comma 0 plus 1. I'll come out and I'll say okay, uh, if fray dot um, get if fray dot size, let's say if fray dot size is greater than 2, greater than 1, then continue the outer loop, no chance. Let's say this loop is q, so continue the loop q. If fray dot size is equal to okay, this is for this particular x. So if fray dot size, okay, I think we definitely need it here. We need it inside that loop, that if it has increased, this is the frequency for that particular thing, so that definition must come inside. Sorry. So yeah, the frequency, if it is greater than 1, then continue q. This is hopeless. If it is equal to 1, if it is equal to 0, we can say that might be the easiest case. If it is equal to 0, then continue the innermost loop. Okay, and at the end I will see the boolean, I'll see the flag. If I don't need to see the flag, actually I can say pw.println, I'll print it. This is x, so I'll print this and continue q, right? Size is 0. If size is 1, then I will make a distinction. Frequency dot size is equal to 1. Then I'll have some cases for so what is the minimum? Minimum equal to, let's say, 10. For int u in that frequency map, I'll find out that okay, min is equal to math.min, min comma frequency dot get, okay, it will be frequency dot key set. So I'll find out the minimum frequency. The minimum frequency must be 1. So if it is frequency dot get u, min is this. What next? Coming outside, we can say if min is equal to 1. Is it the right direction? Min is equal to the minimum of min and that frequency. If the min is greater than 1, if the min is greater than 1, then that's a horrible thing. Then we'll basically say continue q. This is not possible. Continue q. Else, if then that means it is equal to 1. Now we will say okay, if flag is false, then continue. If flag is false, that means already there has been one discrepancy before. So if this is the case, then continue q. Continue q. Otherwise, we will turn k to flag to false, saying that okay, now we have seen a discrepancy. This is the first discrepancy. You can allow this, so you can continue the for loop. Yeah, no use of this continue statement, but no harm as well. I'll come outside, print ln x and continue u. Logically, I think this should be correct. I'll run this. Too many cases. Sorry about that. Have I taken the input? Yes. Okay, what is CH? I've not taken CH, is it? What have I compared? CH. So So this frequency here, I basically need to have ch of j minus a, something like that. Anywhere else? Okay, later on as well. Yeah, this is fine. It ran into an infinite loop, is it? Let us check what with one test case now. Index out of bounds 387. 387 over here. Ch minus 1. Why? J is less than n, we checked. And n is the size, right? N is the size. So I less than x, j equal to I, j less than n, 4, j less than n, then why is it leading to this error? Ch of j. Yes, it is 4. How is j reaching 4? J plus equals to x. (387) Ch minus a. This is slightly outside my understanding. Ch minus a. Clearly the issue is in Ch. The frequency ch. Okay, next int 1 4 ABAA. If it doesn't contain, we are updating AR. We are not updating CH. I'll check the version once. First of all, it's taking a lot of time. This was not expected. Then it is saying something like this. So let us go from scratch. What is x? And will that matter? When j is equal to I, j is always less than n. So does it matter? Let me print n plus ch dot length plus j. Okay, it's printing a lot of things. At the end, it is 4 4. N is, where is that n? Okay, okay, I did this blunder. Okay, okay, okay. I forgot actually updating this. So n, why should we again do that thing? This is what you need to do. Yeah, that should be fine. But that time taking was a bit scary. Does it mean end root n is actually bigger than it is allowed? Figure out. Okay, this is fast. This one was fast. 440. The answer is 4. It is supposed to be 1. So what is happening? X equal to 1. So we can say we can replace this by x plus chj, and then let us try to see. Sorry, this one only. The answer that we expect is 1. We are getting 4. Yeah. So 1a, 1b, 1a, 1a. This should be correct. Fair dot size greater than 1, that is not correct. So continue q. That will not happen. Fair dot size equal to 0. That is also not correct because it is equal to 1. If it is equal to 1, we didn't need this condition. But anyway, min is equal to 10, and then we dot get u, which means we should have 1 and 3. So min should be equal to 1. So we will have something like this. Flag is initially true, so this will not happen. Flag equal to false. Continue. Continue. Continue means okay. I'm sorry. No, that is correct. So for this particular I have done it. For this particular I, it is matching. So for x, for a particular I, for a particular j, if I see this, this is actually my debugging pattern, my debugging way. I should have actually solved this faster. But anyway, okay. So we are looking at this 0, 0, 0, 1, 0, 2, 0, 3. Then we are stepping into 2, 0, 0. In 1, 0, 0, why aren't we sticking to this? Ch minus a clearly has two different values. So the frequency array, the size should be equal to 1. We started with flag equal to true. Okay. So the min should be equal to 1. Flag is equal to true. So now I am converting the flag to false, and when I'm saying continue, next time it will, okay, the first time it will look at 0 and 2, I believe. Index 0 and 2 which have a and a, otherwise index, yeah. Wait, if min equal to 0, sorry, if this is 0, then we are doing continue. Fine. So we are going there, and eventually when we will come out, what are we doing then? Print x. So yes, this should be the ideal way. When are we stepping into continue q? Are we doing that? Flag equal to false, continue q, that is correct. Min greater than equal to 1. Oh, sorry. Repetitions. So this is 2. If it is 2, then this is what we are following. If it is 1, it will never be 0 actually. So that was my mistake. Sorry, I was counting the frequencies, but that was my mistake. Lost it from the clipboard. Here it is. We have 1, so that's fine. That's a good thing at last. We can have another one. Let's say this one. The main thing now is the time complexity. It is 2. Yes, it is 2. So I can now try out with the entire thing by suppressing this. No other logs, I believe. So the only thing to see now is, does it pass the test cases in the time limit? I believe 1 4 13 2 10. 1 4 13 2 10. Yes. So that is the only point. It's fair to see, since we have spent so much time. It's fair to see whether it passes or not. Else I'll brainstorm in a slightly different way. Okay. First test case. Not a big deal. There were no big numbers over there. Second test case should actually tell us most of it. Running on test 2. Okay, running on test 7. So we are on the positive side. Okay, that's good. 12 test cases passed. So we are not doing bad. Okay, accepted. Fine. So the hypothetical thing, we were trying to estimate the time complexity, but fine, we have somehow managed to finish it. Okay, let us look at F and G. We have 57 minutes. So basically in this previous problem, what I eventually did is, maybe I'll explain a bit. So maybe through this explanation, yeah. So what I have done is, I've used this map as a kind of memorization kind of thing. So remember the result that you have already computed. So if some hack is there giving me the toughest number, which has the maximum number of factors every time, then I will basically reuse the value in that case. So it can't give me the same big number so many times. It has to give me different numbers. That I have used map, and I have said, okay, map.put n comma ar, and then fetch from the map basically. Uh, Take the AR from the map if it contains. Otherwise, calculate and put in the map after sorting, so that we don't have to sort every time. Sorting means now the smallest factor will be at the beginning, largest factor is at the end. Now we are saying go through all the factors. AR actually contains all our factors. And flag basically means how many times it has got violated, or has it got violated, or is it free of violation till now. Flag can be false. False means one violation. And then when we see another violation and we see already the flag is false, then we will say, okay, that means we have already reached two violations. So we will not proceed further. So what are the cases where we are denying? We are saying this is not a factor. This is one case where we are saying that number of different elements is greater than 2. So we have not just A and B, let's say A, B and C at three different positions which are supposed to be the same. Here J moves to those positions which are supposed to be the same. So if I see different values, then I will say that ignore this. This will not give you the answer. Then I'm checking whether there is only one or not. If there is one, fine, it is the best. If there is only one, very good. Don't do anything else. That means only one value is repeated. So search for the next position that is recurring. So what I basically mean is, yeah, I'm first checking this when I is equal to 0. Then for I equal to 1, I'm basically saying when I is equal to 1, I'm checking this one, this one, this one, this one, whether they are the same or not. Then for I equal to 2, I'm basically checking this one, this one, this one, this one. Then for I equal to 3, I'm basically checking this one, this one, this one, this one, and so on. So that I is controlling this. For I equal to 3, I'll take J in this manner, in hops of 4. Okay, that's it. Coming back. That's it. And now all the true false things. That's it. So this has passed. That's good of us. Now find the minimum height of a rooted tree with a plus b plus c vertices that satisfy the following conditions. A vertices have exactly 2 children, b vertices have exactly 1 child, and c vertices have exactly 0 children. If no such tree exists, you should report it. So yes, you can view this in this yellow, purple and red kind of thing. So A is basically the number of yellow nodes which have at least 2 children. Uh, Red is actually the B. B is actually the red which has only 1 child, and C is this purple. So we have to create a tree, is it? Okay, find the minimum height of a rooted tree. We have to create a tree. Uh, so we have to return the height or the, okay, only the height. That's good. That's good. Hmm. Rooted tree. So we can't have this kind of a thing, that this has these two, and then this also I mean, this has these two, and again this has this one. We can't have this. This is neither a tree nor a rooted tree, so we can't have all those things. We are basically getting the structure. Now, we are getting the leaves, that is C. So C basically, C gives us our leaves. Next, B have one child. Okay, so just on top of the leaves we can say we have B. We have B on top of C's. If B is small, no issues. If B is bigger, then also no issues. But the minimum constraint is that C has to be greater than equal to 1. B can be anything in my understanding. And A. A basically tells you how much branching has happened. One, uh, one node in this category of A basically means something like this. Okay? And this means at least two leaves. The moment I have another one, it means at least one more leaf. So from A, my actually, what I'm thinking is it means actually there has to be at least A plus one leaves. Because each time it comes, it adds a leaf. It actually it does one more branching. A plus one leaves. Can it be more? No, it cannot be more. So this is bound. So what I'm basically finding is that A plus 1 looks to be equal to C, right? Number of leaves. Number of branching is equal to C, B can be anything. Is that the condition? A plus 1 equal to C. Yes, 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 yes. Okay, fifth one is minus 1, right? So this one is no. 3 plus 1, 4, right? 8 plus 1, 9, 24. Okay, this is no. This is again no. So we have hit the right conditions. Now B. B we have to distribute in such a way, and A and B we have to distribute in such a way. Now the height is the factor. So we know whether it's possible or not. Minus 1 we know. So uh, if C greater than equal to 1 and A plus 1 is equal to C, which will be the case if A plus 1 equal to C. I think since all are greater than equal to 0, so this is the only condition. If A plus 1 equal to C, then we can say, so it's possible. The answer is greater than 0, otherwise minus 1. Okay, 0 is also possible. How? Okay, so it is starting from 0, fine. So greater than equal to 0. One node basically means the height is 0. Okay, so somehow the distribution has to be such. Now the distribution of A doesn't matter much. I mean, doesn't matter in the feasibility end. In the feasibility side, it doesn't matter. So I can distribute it, right? I can distribute it, and uniformity is the key. If I have to minimize the height, it has asked for the minimum height. So I will try to distribute it. I will say that, okay, uh, 1 over here, 2 in the next level, 4 in the next level, and whatever remains, let's say 2 remains. So 2 will come over here, and then I will balance the B in such a way that, okay, over here, so something like this, let's say I've exhausted some of them. Here 8 were possible over here. 8 were actually possible. So we have 4 in the previous level. Let's see this. We had 4 in the previous level. Now below that, 8 are possible if we make them branch, right? No, if we put anything, 8 are possible. So we can say, okay, divide the A's and B's over here. That should be helpful in my understanding. Yes, that should be helpful. Why? Because we are putting the A's before, because it will help in the branching. Faster you do the branching, lesser should be the height, because at the beginning you are making the branching. If you see this, how many? 7 nodes, and now I'm putting 1, 2, 3, 4, 11 nodes. Now if I do that single things before, 1, 2, and now if I do the branching, 1, 2, 1, 2, 1, 2. Clearly this is adding. This is adding. So at the end you will see that the height will be more. So my hunch is that those A's will come first. So let's say, okay, here we have something. Hmm. What if our A's and B's are not sufficient to fill this? Our C's will be sufficient. We already know that. But we have to fill with A's and B's. We have to try with them in a distributed way. So first let's say our A's, A, 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 and then let's say now the B's. So B, 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 and then I will put the B's once again over here. B, 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 whatever are required, and then I will keep on putting the A's from after that. I mean, here also I can put B's, I can put a B, I can put a B, and then I will start putting the C's here onwards. Here onwards, I'll put the C's. Okay, so how many are there? A plus B plus C doesn't cross this. So we can put one by one, right? We can put one by one. So this should be a fairly easy problem in terms of implementation. I hope I was actually projecting this. So yeah, this one we are getting A's and then we are getting B's and then we will get all the B's and then all the C's. So we can do one by one in this way. Fine. While I'm putting the A's and B's, I will mark what is the quota for the next level. According to that, I'll put the C's. So feasibility side. First, I'll verify the feasibility. So ABC. Let us do it now. Let us implement. A, B, C, and first the feasibility thing. I'll not use the map. I'll say okay. If A not equal to C plus 1, sorry, A plus 1 not equal to C, then pw.println minus 1 continue U. Otherwise the story begins, and we can put one by one because A plus B plus C is limited up to 3 into 10 to the power 5. That is the best thing actually. So I'll do in this way. Int cap is equal to 1. While A plus B plus C is greater than 0. I'll do this. So int next cap is equal to 0. Next cap basically means, so here if we have A category nodes, they will create capacity for 2 nodes in the next level. So I will understand, okay, how many nodes can be in my next level in that way. And now I'll start distributing. I'll say while cap is greater than 0, I'll say cap minus minus. If A is greater than 0, A minus minus, next cap plus equals to 2, else if B greater than 0, fine, B minus minus, next cap plus equals to 1, Okay, there is a catch now. I think the way we are doing, definitely the leaves will occupy the last level. No, we need to be careful that they are not occupying. I think it should be fine, but whether we are putting things in the wrong part or not, we have to be careful. So else, in this else part, the next capacity should not increase. There we should not put anything. So C minus minus, next capacity should not change. And now I'll say, okay, next cap equals to the next cap. Int h equals to 0, h plus plus. Over here, when we come out, we print h. I'm wondering if the answer can be so easy. Three, 1, 2, 2, minus 1, 4, 7. Okay, not matching. 2, 1, 3. Okay, the first, so I think we should start with minus 1. Yeah. Because the first time, the first level also we are counting over there. That is not what it should be. So let's start from minus 1. Okay, 2, 0, 1, 2, 0, 1, 1, 2, 0, 1, 1, minus 1, 3, 6, minus 1, minus 1, 3. Minus 1, 3, 6, minus 1, minus 1, 3. This one matches. Okay. So I'm actually using a greedy method, putting the yellows first. In which case, does putting the red first, I mean, that should not help me. In which case, leaving the red for later should help me before the blues. That also shouldn't help me. I'll go for this solution because I think this should work. So my understanding of this div 3 contest is basically it's highly observation based, intuition based. So there is less algorithm over here, less use of data structures and algorithms per se, which is fine. Good for practice sometimes. Usually, the best I think is a mixture of everything. We should have some algorithmic parts, some of these observational things. I think all of these are mostly observational things, but it's fair to improve in such areas as well. Accepted. So the hypothesis was correct. Finally, let us see if there is something interesting in G. We still have 39 minutes, so worth giving a try. Okay, playlist consisting of n songs, 1 to n. I has genre GI and writer WI. He wants to make a playlist in such a way that every pair of adjacent songs either have the same writer or are from the same genre. Okay, either GIs are same or WIs are same for any pair of adjacent songs. Okay, he calls such a playlist exciting. Both GI and WI are strings of length no more than 10 to the power 4. Okay, they are strings. It might not be possible to make an exciting playlist using all the songs, so the shuffling process occurs in two steps. First, some amount of the songs are removed, okay, and then the remaining songs are rearranged. Yeah, fine. Since they don't like the songs get removed from the playlist, he wants the making playlist to perform as few removals. Yes, the minimum number of removals such that this is possible. Okay, so we have to adjust output. What is the minimum number of removals? Hmm. This sort of seems like a graph thing to me, but let me see. We can mark an edge. I mean, we can mark edges. And okay, n goes to 16. Interesting. Hmm. And then, okay, so from where to where we can go, we can do this in a lot of ways actually. This looks like a Hamiltonian path kind of a thing to me. That can we cover a certain subset or not? So 16 elements means what? What is the number of subsets? How many subsets of nodes are there? 16 elements. 16 elements basically means 2 to the power 16 subsets or masks. So, and comparing, I mean, checking whether song I and song J can stay adjacent or not is pretty easy. So we can make those edges. These are the subsets. And now, so I can represent in this way. Let's say I have 1, 0, 1, 1, 0, 1. That basically means I have taken these four. I have held these four. The rest two maybe are removed, but these four songs can stay together. Um, hmm, correct. So I think this is a straightforward thing. So basically, you need to see, consider all the songs as nodes. Consider all the songs as nodes, and then you need to form a kind of Hamiltonian path if possible. Otherwise, the longest path covering maximum number of nodes. So something like this from here to here, then here to here, then here to here, then here to here, then here to here, something like this. This might be the maximum path possible. So either way, so this DP plus bit masking kind of technique can help us. DP plus bit masking, if I use, that is going to take 2 to the power 16 subsets. 2 to the power 16 basically means 10 to the power 10 to the power 5, right? 10 to the power 5 into 16. So 16 into 10 to the power 5. So complexity wise, that is fine. And then these are the number of states. Sorry. These are the number of states. What will I maintain? I'll maintain something like this. dp of ij, where I is that mask of which elements are covered, and j is basically my song, the last song, let's say. The last song. So it goes from 0 to 15. Cool. This should be solvable. Uh, Some of these do not cross 4 into 10 to the power 5. Okay, there are many test cases actually. So 10 to the power 5 into 16 is the time for each test case, which is 10 to the power 6 into something. And now there are 1000 test cases. Okay, overall test case, this is given. Okay, what I wanted, that is given. So this is 2 to the power 16. I don't have to multiply that by again 1000 times. So that is fine, very good. Next thing is, this sum, does it matter? I'm comparing it once, so why should it matter? 10 to the power 4, what is the maximum number of comparisons? Sum doesn't exceed 4 into 10 to the power 5. So, okay. Are they of the same length? Not given. 10 to the power 4, if I just compare 16 and 16 strings each time, should not be a big deal actually. I'll form a comparison matrix to store that, okay, which two strings can stay side by side, which two songs can stay side by side, and then I'll use that kind of matrix, matrix basically. It's a one-time thing, and anyway, we have to do that. There is no other choice. So we can optimize, but I'm not finding enough motivation to optimize that. So we'll do the brute force thing there. So let me see if I can try to implement this. This is a DP plus bit masking. I'll try to explain as I code it. And how much time do I have to code it? Let me take a look at that. Okay, 33 minutes is decent enough. I've got T, I'll have N, and I'll have this GI and WI. next, sorry, yeah, next int, and string, and now I have G and W, new, sorry, sc dot, sorry, new string. Similarly, this one, this is W. Now, how are we taking inputs? Each line contains Gi and Wi. So for I equal to 0, I less than I plus plus, Gi equals to sc dot next, Wi equals to sc dot next. Hmm. Hmm. Gi, Wi I have taken. Okay, now the comparison matrix, which is something like this. Boolean B, or is, let's say C, C for comparison, equals to new Boolean NN. Okay, for I equals 0, I less than, you can do this, that CII is always, or just ignore that. For j equals to 0, j less than n, j plus plus, CII equals to true, and if I equals to j, continue, otherwise Cij is basically going to be whether they are matching or not, whether Gi is equal to Gj or Wi is equal to Wj. Sorry, not equal to, it's dot equals. Dot equals Wj. Okay, so this gives us the comparison. Fine. Now this comparison we have to use in our actual DP formulation. So I'll take the DP somewhat like this. Int DP. This should also be Boolean. So initially they are all false. Minimum number of removals. Fine. DP equals to new Boolean. Okay. Now I will take those many states, which is 1 left shift n and n. This is my number of states, and then I will say that the base case basically is going to be, for the base case can be 0 only. No, the base case should be different. So for I equals to 0, I less than n, I plus plus, only if that element is present, that is possible. Only that element, and that is the last element. I'll do something like that. I'll say, okay, dp of, what is the mask that represents only that element is present? We can do in this way. Basically, 1 is present means our mask can be zeros or 0, 1. If 2 is present, we can have, oh sorry, this is if 0 is present, first element. If similarly 1 is present, we can have 0 dot 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 1 0. If 2 is present, we can have 1 0 0. So the position of the 1 in this value will determine which one is present. So I'll use that. I'll first say, okay, 1 left shift I is present and I is the last one. This particular state is possible. Then I'll go for the bigger ones. I'll say, okay, for I equals to the bigger numbers, which start from 2, I less than equal to, sorry, I less than 1 left shift n, which will fit in int, so I'm not worried. Now I'll count the bits. So int count bits, you already know how to count the bits. Int n, and I'll do something like this. Int c equals to 0 while n greater than 0 if C modulus, sorry, n modulus 2 equals to 1, count plus plus, n right shift equals to 1, or I could have just written C plus equals to n and 1, all those things are there. Finally, you just have to return, uh, okay, right shift once. Is this wrong? Oh yeah, and right shift equals to 1, and then return the count, that is C. Okay, now this is my count bits. I will say that for I count the number of bits, CNT is equal to count bits I. Next I will say that why is this, okay, it is not static, it's a Java thing, static. And next I will say that, okay, continue. How to approach this? I will say if you have only one bit, then no need to do anything. CNT equals to 1, then or less than equal to 1. I mean, that is not possible, but fine. Less than equal to 1, then continue. We have already finished that part. Now, I can do something like this, that for I equals to all the bits basically. So j equals to 0, j less than n, j plus plus. If I and j, 1 left shift j is greater than 0, this means the jth bit is set. Then I will basically try to see if okay, what can be my neighbors for this. I can try to introduce j. So I will basically say, okay, y is equal to I XOR 1 left shift j. So this is the number, this is the state where we will come from. What I'm basically saying is uh, this represents, let's say 0 0 1 0 1 1. This represents that this element, this element, this element is present. What I'm saying, let's say we are introducing this element in this case. So is this state already present, 1 0 0 1? So I'm XORing this, I'm doing a XOR of this, and I'm checking is this state present. If this state is present, then introduce it. I mean, then attach that new node to this one. Fine. So I'm going to XOR it. This is my y, this is that previous state. And then I'll say, okay, in this state, what are the last elements possible? So I'll do something like this. For int k equals to 0, k less than n, k plus plus. If k is set, if the bit k is set in y, that means y and 1 left shift k is greater than 0, and if this is the case, and we have, I mean, this comparison, they can stay side by side. The comparison matters. So basically, k and this j can stay side by side, right? It is j, right? Yes, is equal to true. If they can stay side by side, then I can use that. I can say, yeah, go ahead. Ckj equal to true. Also another case is required, and there is some dp of y which ends in that k. If that is also equal to true, you don't need to write equal to true, I'm just writing that for clarity. So yeah, if this is the case, then I can say, yeah, dp of I j is equal to true. I is that, sorry, I is not the mask. Yeah, I is the mask and j is the bit. We are ending at j. So yeah, so what I'm saying is there it was ending at k. Now k is a neighbor of j. So I can put j next to k, and then this is fine. Okay, equal to true. Great. And fine. Okay. Now equal to true means I can continue with the next I actually. No, actually with the next j. That ending at that position we are done. So we can add something over here, r colon, and I can say continue r. But I'll have something different. I'll say okay, int max equals to 1. 1 is the best answer always. I mean, always an answer. Over here I can do max equals to math.max, max comma count bits, uh, count bits I, right? I has become possible, so it's I. Correct. So, I think you should not try to skip more. You should not say if we have found some max now, don't try that. If count is equal to the existing max, don't try it. We should not do that because that may lead to a better answer. We'll be missing that. So let us see. Okay, I have not printed anything. That's bad. Println max. 0043. After a lot of effort, it's only a very small thing to print. It should have asked us the entire order. 1431. Something different. Okay, how many to be removed? So it should be n minus max, right? It should be n minus max. This many you have to remove. The minimum you have to remove here. So I've taken maximum, how many can be there. So how many do you have to remove? Minimum, that is n minus max. 0043, is it so? Yeah, 0043. I'll take my hunch, we have 20 minutes left. I can rectify mistakes later on, if any. Let's see. Okay, it's accepted. So that's a good thing. The problems were pretty observation based, except the last problem where he used a fundamental DP technique known as DP plus bit masking. I actually want to take a lecture on that. I actually want to show how that DP plus bit masking problems can be solved. Again, one of my favorite topics. I love DP, I love bit masking. More than DP, I love bit masking. So it was pretty easy to actually see that DP plus bit masking is finding implementation here. So not very tricky, I would say. But yeah, that's it. If I again look at or show you the implementation, what I'm basically doing is I'm forming a graph. These are my nodes. Each song is my node. And then I'm saying the edges are basically existing wherever two songs can stay together adjacently. I'm putting an edge over there. And then I'm saying, okay, start basically with every subset. What subset of songs can exist? And one thing that matters together with it is where it is ending. If you don't know with what song it is ending, you can't know whether you can attach another song or not, because that is what defines an edge. I mean, any song cannot stay beside any song. That is given in the question. Who will stay beside whom? So we have to remember, okay, either what it is starting with or what it is ending with, wherever we want to add the new node. And DP is covering all those cases. So actually, DP means two things: optimal substructure and overlapping subproblems. What is the overlap over here? When I say 10101, this particular state, ending at, let's say, the third node, then I'm abstracting, okay, what is the exact ordering of those songs? I'm not saying what is the ordering of those songs. That can be huge. So the ordering of the songs, actually the songs can be arranged in how many ways? N songs can be arranged in n factorial ways. But here we are actually considering 2 to the power n subsets. 2 to the power n is less than n factorial. Right? Above a certain n, if you go, above n equal to 3 or n equal to 4, you will see that that becomes very clear. I think above n equal to 4, something like that. N equal to 4, it is 16, and 4 factorial is 12, 24. Yeah. So n equal to 4, this is less, and if you go further, you will see that this condition holds. So we actually say, okay, take the subset form. This is where bitmasking actually helps. If we don't use bitmasking, our number of states will be more. If we take all possible arrangements, that will be very high. If I take n factorial, that is 16 factorial, 16 factorial will be actually very high. You can calculate it. 16 factorial will actually be very high. I think we calculated it in one problem, right? Let us see. 2 and 10 to the power 13. You can't have so many. Up to 10 to the power 8 we can have. You can't have 2 into 10 to the power 13 or something like that. So yeah, so I'm taking subsets. There are 2 to the power n subsets. And for each subset there are only n states I need to consider. What is the ending point? I mean, for that ending point it is possible, and it's possible that for multiple ending points it is possible. So I'm not just storing one endpoint. For all possible endpoints, I'm storing this Boolean thing. So this is, I mean, there is a very common problem that is related to this, that is Hamiltonian path. If possible, I will share a video on that in the coming few weeks. Okay. This is a problem that is very similar to this. Okay, that was nice. So problem by problem, if we go, the first 2-3 were actually brute force, and then we had to think in terms of the time complexity what is going to allow, but most of it actually was intuition based, basically thinking in the wild, figuring out what can actually work in this case and solving it. This was a spring question. I would say one takeaway for all of you should be that for all these problems, we did not use any big data structure or algorithm. For the last one, yes, I used a fundamental algorithm, but not for the other ones. So the takeaway should be for you should be basically that we don't always need hard algorithms and data structures to solve problems. But your observation should always be very accurate. I mean, it should be very fast. You should be fluent in those things. You should always be aware of what is happening, what are my constraints, etc. For every problem, that is what I did. I observed what is given, what are my constraints, how far it can go. The moment I saw that the sum of A, B, and C can go only up to here, I just proceeded in the basic way. I could have done a bit, I could have done it a bit more optimally. This is currently big O of A plus B plus C. It could be done in logarithmic time. Log of A plus B plus C. But the question did not demand that. Had the question demanded that, we would have done it. But this particular line basically makes it clear that it doesn't want so much. So that's it. I hope you will find this video interesting. I'll upload it after 15 minutes. I'm hoping that it wouldn't exceed this time, it wouldn't run, the contest won't get extended. So after 15 minutes, I'll be uploading this. So take care, keep coding, see you all in the next videos, and let me know if you solved any problem in a different way and if you feel your solution was better. Let us see how our peers performed, our genius peers. These two are very good coders. Tourist sir, I wouldn't mention much about him. He is a legendary grandmaster. He is a legend. And we have second thread. It's taking some time to actually load. This is bad. It will be good if it is my internet connection. Yeah. Otherwise, I'd be sad to see it go unrated. Okay. Second thread solved it pretty fast. In 36 minutes, he was done with all the problems. So it would be interesting to see how these guys solved it. Okay, I took 1 hour 54 minutes. Not pretty impressive. Can be improved, especially over here for C, for D, for E. F was actually very easy. So yeah. Right. Chalo then. See you all in the next videos. Take care. Keep coding. Let me know how you are feeling about these videos. Please share with folks who might find this informative, who can get insights from this, how I am solving, and can actually tweak their own solving process in that way. And see you all in the next videos. Let me know in the comments how you felt, and if you have solved differently, or if you want to see some other approaches for solving the same problems, then let me know. Chalo. Thank you.